Story of Black Holes, 1917 to 2023. The Earth. What happens if you throw a ball high up in the sky? It will come down due to gravity. What happens if you dive to the bottom of the ocean? The pressure will be immense. A person would get crushed due to immense pressure. The pressure due to gravity. What happens if you bury something 10 feet deep? What happens if you bury something 100 miles deep or 1,000 miles deep? The pressure would be huge. Most matter turns into diamonds at this depth. The Earth. The center of the Earth is 4,000 miles deep. Imagine the pressure at the center of the Earth. There is one big metal ball holding the pressure due to gravity. The gravity is pushing down non-stop. The Sun. The Sun is 1 million times the mass of the Earth. The center of the Sun has a nuclear reactor. Nuclear force holds gravity and keeps the Sun from collapsing. What happens for stars bigger than our Sun? In 1920, scientists calculated that if a star is much bigger than our Sun, there is nothing to stop it from collapsing all the way to zero volume. The idea of a black hole was born. This is theory. There was no evidence for that. There was no evidence that such thing really exists anywhere. The picture on the right shows a large star known as UY Scuti compared to our Sun, all around here. Imagine the pressure due to gravity at the center of this huge star. At some point, nothing can hold the gravity back. There is no force that can stop gravity. The pressure at the core of large stars are so high, no other force can stop the star from collapsing all the way to zero volume. What would be left is a black hole. Nothing can escape the immense gravity. Not even light can escape. Hence, we would not see anything. Anyway, this was all theory. So, do we have evidence for black holes? As I said, this was all theory. What evidence we have that black holes exist? Let us go back to our Sun again. Our Sun emits light. We all know that. It also emits a small quantity of X-rays. X-rays that you would take when you go to a hospital. Same with other stars. Normally stars emit only a very small quantity of X-rays. X-rays are very energetic compared to average light. X-rays can go through our bodies. More powerful X-rays can even kill us. In 1933, Carl Jansky, an astronomer, found X-rays coming from the constellation of Sagittarius. Constellations, there are many constellations. The most famous one is the Orion. We all have seen the 3 stars of the belt of the Orion. But Sagittarius is a different constellation. And these X-rays were coming from somewhere in this Sagittarius constellation. And he called it Sagittarius A star, this X-ray object. Star means something special, because stars normally don't star here in this A star. Normally stars do not emit X-rays. If they do, it would be very, very small quantities. And if our Sun were to emit X-rays in large quantities, we would not be able to be alive. Sagittarius A star, our X-ray object. But there was another surprise. This X-ray emitting object was coincidentally located at the center of the galaxy. And this is our galaxy, and Sagittarius A star is somewhere here. Sagittarius A is another star. That's a star. Sagittarius A star is, we don't know what that was at that time. We'll find out. This is our galaxy, and this is the central region of our galaxy. At Carl Jensky's time, we did not have telescopes powerful enough to zoom to the center of our galaxy. Once we built better and better telescopes, we were able to zoom into the center of the Milky Way. Here you can see stars are moving very fast around something. This is 20 years of data that was compressed into 4 seconds. And whatever this object lies somewhere in this box somewhere, and the star comes and goes around very fast. And this object cannot be seen. There's a white dot is placed, and just to indicate what this object is. And that is our Sagittarius A star, our X-ray emitting object. Movement of stars at the galactic center. In the 1980s, astronomers started to notice that stars move very fast around this X-ray object. But there was nothing that can be seen at the center. The animation shown here is data collected over a period of 20 plus years, compressed into few seconds. Now planets move around stars. Our star is million times heavier than our Earth, million times heavier than our Earth. What could move a star, all these stars, what is so powerful out there that can move all these stars around it? Let us look at a person swinging around a rock. Let us say you can see only the rock. You cannot see the person. Let us say the rock is only 1 ounce. Then you can say the person swinging the rock is a child. It's only 1 ounce. Let us say the rock is 1 pound. Now the person has to be an adult or a big child. Let us say the rock is 1,000 pounds. You look at this and you see a 1,000-pound rock is moving around. And then you know this whoever at the center is not a person. No man can rotate a rock that is 1,000 pounds. So the center, whoever rotating this 1,000-pound rock, is some kind of a machine. What's going on at the center of our galaxy? There are a lot of stars at the center of the galaxy. All stars go around the Milky Way. Our sun takes 200 million years to take 1 revolution. We are outside the center of our galaxy. We are in one of those arms, and then we go around the center of galaxy 200 million years for 1 revolution. How to calculate the mass of Sagittarius A star? Now we know where this Sagittarius A star is, but we don't know we cannot see anything, we just get some X-rays. How can we calculate? From the very high speed these stars travel, one can calculate the mass of Sagittarius A star. And we see how it can be done. The calculated mass of the unseen object is 4 million suns. 4 million suns. This unseen object cannot be a star. The stars cannot be that heavy. Then what could that be? It simply cannot be a star. It's a black hole. S2 is a star, one of the stars going around this unseen, unknown object. S2 is 15 times the mass of our Sun. It is speeding around the black hole at an incredible speed of 3000 miles per second. It will go from New York to California in a second. What object can take a star that is 15 times heavier than our Sun and throw it away at a speed of 3000 miles per second? S2 makes one orbit every 16 years. S62 is another star that's going around the central black hole. This comes very close to the black hole, similar to the distance between Uranus and the Sun. It is 6 times heavier than our Sun, and it is much faster than S2, and it travels at a speed of 18,000 miles per second. Fast forward to 2022. Our telescopes were so powerful that we were able to focus to the X-ray source, to the middle, using very high resolution telescope, and we were able to take a photograph of the black hole. Wait, if the black hole cannot be seen, how can we take a photograph? When matter falls into the black hole, matter gets heated up to millions of degrees. Then matter that's fall into the black hole glows. That's what you see in the picture. Once matter goes into the black hole, it will never come out. Not even the light can come out. It took more than 100 years to settle the issue of black holes. Now we have started to talk about white holes. How long would it take to settle the issue of white holes? What is a white hole anyway? Stay tuned to my channel to know everything about white holes. Thanks for